Hi there, guys. Actually, I'm working in Moscow Exchange Group, and I will be trying to be not from Moscow Exchange, but from Hyperledger community. And I'd like to start talk about confidentiality with small introduction about Hyperledger, because it was sometimes understand it not so good at the moment. Is it working? Oh, yeah. So what is Hyperledger? It is not blockchain platform. It is just one of 52 Linux Foundation projects. It is umbrella project for open source blockchain and smart contract technologies, which is welcome to any kind of source code to be contributed according to Apache license. It is focused on open protocols and standards, and we spend a lot of time with contributors from leading companies like IBM, like Chicago Exchange, like I don't know, Intel, and even small companies like startups called Iroha and Soramitsu also participate in making a kind of standards for blockchain technology. And it includes a variety of blockchain with any kind of consensus that can be imagined, and storage models and services for identity and access control. And the focus of this presentation is about confidentiality. I'm starting this with quote from Hillary Clinton about confidentiality and the importance of it, which killed her during last elections. It's always important because always there is people who want to pay money for your data. And from my first university course about data and data mining, I know that always data has price. So what are challenge properties about? We need to have confidential distributed ledger. We need it scalable, immutable, traceable, and auditable. Only in this case we will have operations inside the technology, and all will be happy. What are problems here? Poor practical experience at first. Actually, when we ask people from stock exchange business, only 1 from 10 understands what is confidentiality question. Why not to store just digits without any kind of ciphering and without any kind of encryption? Data domain specifics, support of selective transparency, choosing between scalability and confidentiality. And last question that we addressed to digital asset holding at first, do we really need consensus inside the system? So what we can do? Proprietary solutions that promise and give no details, or open source code that contains clear described algorithms with proof of its correctness. Actually, I hope that most of all people want to choose the second one. So possible ways to solve it are following, from encryption to fingerprinting, channels, segregated ledgers, confidential transactions, zero knowledge proofs. And I'm not so big specialist in cryptography in comparison with Vlad or with other people that works full-time for these ideas, but I will try to managed with some features of each part. Encryption is a good way known from, I don't know, from the start of ledgers. Transaction data can be in common ledger. Only entitled participant can decrypt data. No verification by entire network because it needs to be encrypted. No guarantee that historical data remains confidential even in the event of subsequent compromise of encryption in the future mainly. And data domestical restrictions because of standards of encryption provided by each country. For example, in Russia, we have special standard for hash function called stribok. It's name of one of gods in religion. Same god? Yeah. Second one is fingerprinting. Just record a fingerprint of data set in every block. Compact proof of existence. Then we have no consensus needed. Also reduced traceability and auditability, unfortunately. But still, we have a lot of distributed ledger projects with huge amount of investments that are doing fingerprinting. Next one are channels. I think everyone is familiar with Lightning and other technologies. I will not describe to save your time. Next one is segregated ledgers, when you can choose bilateral, trilateral, or partial trees, where you can make a kind of partial consensus, and you can provide information only to subtree that you are trusted in. It is a good approach with excellent scalability, and I hope that we will have a lot of applications of this approach in next years. Next one are confidential transactions. We already heard about it from Zkasnark presentation, and it is mainly about additive homomorphism of encryption, not about multiplying. Proof of each output then takes a lot of size of data. Proof is limited. You need to have non-negative check, but anyway, it's working, and it's one of approaches for technology. And the last one is zero knowledge proof. You all heard a lot in previous presentation, so to save your time, I will not spend time on this slide. And the last thing is actually most expensive smart contract or code is one with bug. It was answer to one of questions in Vitalik's Q&A session in Skolkovo before DAO attack, and it's true because of history. So let's do this together. Let's make it with open source, and let's use technologies that are proven for confidentiality to save the data.
Perfect.
Thank you.
Thank you so much. Thank you, Alexander. We are ready to take questions. Is there any about confidentiality? Yay. Ari, sure.
Please go ahead.
So, could you maybe go into a little detail about how Hyperledger is looking into zero-knowledge proofs? Are you actively looking into it, and how exactly?
Good question, Ariel. Actually, during December of last year, we decided to have a kind of special working group together with IBM and together with few other companies that I cannot name at the moment to make a series of prototypes with Fabric and maybe also with Iroha, with another Hyperledger platform called Iroha, because it is faster one with C++ code to check homomorphic transactions, to check zero knowledge proof with few realizations, and we are open to collaborate on it. If you want to participate, just contact us, and we'll be glad to share our knowledge and to do it together.
Thank you very much. Is there any other questions so far? Yes, no? Couldn't hear. Okay, then we're good. Thank you so much, Alexander. It was a great presentation. We will continue